Glass is an inorganic substance in a condition which is continuous with and analogous to the liquid state of that substance, but which, as the result of reversible change in viscosity, as to be, for all practical purposes, rigid. Properties of glass. Number 1 is glass is somewhat flexible. It tends to bend upon application of force. Number 2, glass bend on the direction where force is applied, causing the opposite side to stretch. Number 3, glass can withstand more bending rather than stretching, causing the opposite side to start breaking. These properties make it possible to determine that glass fragments did or did not originate from the same source, or to determine the manner in which a piece of glass was broken. In glass fractures, glass fractures may be caused by excessive exposure to heat, or caused by impact of the blunt instrument or object, or caused by projectiles. There are 3 types of glass fracture. One is radial fractures. This is the radial fractures originate on the opposite side of the glass because this is the surface which is the first to feel tension as the front of the glass is pushed in. The opposite side is bent backward. And number 2 is called concentric fractures. Secondary fractures having the appearance of circles around the point of impact, connecting on the radiating crack to the other, thus forming triangular pieces of glass. While the radial fractures are forming, triangles are created between the fractures. Concentric fractures, which is originate in the front of the glass, kanang naasya sa front. Pag moagi ang example bala, makita nimo siya sa front. Kung number 3 is conchoidal fractures. A characteristic of glass is that when it breaks, the fractures its upper shell-like in form. It is the having elevation or depressions in the shape of shell. The technical name for condition is conchoidal fracture. Back to the radial fractures, which fractures can be seen on the exit side, and on other hand, the concentric fractures, which we can unseen into entrance side. And this is the fracture caused by blunt instrument object. Through examination of glass, fractures caused by the impact of blunt instrument object will reveal a pattern of radial and concentric fractures. When glass fractures are caused by the impact of a blunt instrument object, stress lines on the edge of both the radial and concentric fractures can be seen. Significance of determining the types of glass fractures. We have number 1 is point of impact, number 2 is direction of impact, number 3 is entrance and exit hole. Point of impact, which called in factor of to determine in glass fractures, is glass is at its maximum strength under compression but weak in tension. An impact on a pane of glass causes it to bulge. Since the side opposite the impact is stretched more, it ruptures first. Radial cracks are rapidly propagated away from the point of impact in short segments. If there is high stress, minute stress crack called Hackley's or Hackle marks may also be observed under the microscope at right angles to the ridge. Number 2 is direction of impact. A shot few inches from a glass will produce a similar result because the pressure of the powder gas itself will smash the glass, and a bullet will make a clear cut hole in the side of entrance rather than or the exit side. If a shot fired perpendicularly, it will give a crater of uniform flaking. This is the what we call radial fractures. Dili nimo makita ang radial fracture nga ang radial fractures makita nimo in exit side, and concentric fractures will be seen on entrance side. In number 3 is entrance and exit hole. Point of entry is where the force is being applied, and it may produce a similar hole than the exit. Kuan ni siya, it's being a force being applied is procedure smaller than the exit. Ang unang entry gamay nimo tan-awon, parehas sa sila makuan, kay the exit is bigger than the entry. For the reason that is the force applied the glass exceed to desired force. Point of entry has smooth hole, while the exit hole has the characteristic of roughness. And this is the example of point of impact. In entrance side is which called concentric fractures, clear cut edge, absence of depression, absence of flaking. In exit side, which called radial fractures, rods edge with depression with flakings. And other hand, this is the illustration of bullet entrance hole. This is the example image, and this is the example image of illustration of bullet exit hole. And that's in other hand, position of the shooter. Perpendicular shots exhibits an even distribution of chipping on the exit side of the glass. Number 2 is angle form of the right. Heavy flakings or chippings on the left side of the glass. Ano siya? Number 3 is angle from the left. Angle from the left. Heavy flakings on the right side of the glass. Letter C is age of fractures. First, fractures exhibits a regular pattern of radial concentric fractures. Number 2 is all fractures presence of a short extension lines. Mubo rin pansa magdagan kay at the end of the radial fractures. And that's all. Thank you, sir.